Good day, everyone. This video contains discussions and demonstrations on practice exercises found in your module, specifically on lesson number 3 of unit number 3, which is concerned on the operations on fractions. Operations of fractions is actually the second half of the operations of rational numbers. We already talked about how integers are operated in the previous videos. And this is video right now, starting with this video, we are going to talk about the operations and fractions. But I would like to make it clear, even if we are just talking about fractions right now, we are always going to go back to how integers works. As to why, we will show it later. For the moment, we are going to share to you the material already opened in the Kotobee Reader application software. This is the third module. Let me click this one. Right. While waiting, again, fractions is the second half of the rational numbers. But still, we are going to use concepts on operations of integers when we talk about fractions. We're going to see it later. Now, this is the content of the module. For a while, it's been loading. Okay, so yeah. So we are not going to talk anymore about the content of this module. We are going to proceed immediately to the practice exercises. For this lesson, we have 4 practice exercises specific for each fundamental operation. So we are going to start first with the addition of fractions. We have 4 problems here, and let's start by sharing to you another window, the item open already in Paint application software so that we could actually scribble down all of our um, solutions. Okay, so in the meantime, while waiting, you may try to review your operations of integers, or we may just simply apply it here. So letter A is concerned on addition of fractions. Okay, you have numbers 1, 2, 3, and 4. Okay, so let's do it one by one. Number 1, we have here the item 3 fifths, 3 fifths plus negative 7 fifths. Okay. When we try to add fractions, there is one rule that we always need to follow. Okay, this is also true to subtraction in the next video. When we add fractions, we need to consider similarity of fractions. Okay, similarity of fractions means we need to make sure that the fractions to be added are similar. When we say similar, they share or they have the same denominators. Again, the structure of our fraction is that whatever you see in the top are called numerators, whatever you see in the bottom are denominators. For number 1, we have denominator 5, denominator 5. In short, these two are actually similar fractions. So when we deal with similar fractions, we simply copy the same denominator, do not add, just simply copy, and then we simply operate the numerators using the operation separated into fractions. So copying that, we have here 3 plus negative 7. Okay? And to complete this, okay, as I mentioned earlier, even if we are now talking about fractions, we will always go back to integers. As to why, look at the numerator here. Again, as a whole, that's a fraction. But when we just observe the numerator, this is actually a process involving integers 3 plus negative 7. So if you still have problems with integers, fractions is also a problem for you. So always go back to integers. As for the final answer here, 3 plus negative 7, may 3 pesos po kayo. Babayaran nyo po yung 7 na utang nyo. May utang pa rin po kayo. You still have negative 4 fifths. Okay, that is your final answer for number 1. Again, what we are considering here is similarity of fractions. Number 2, we have here negative 1/6 plus negative 4/3. Sorry, negative 3/4. In number 2, two fractions now are dissimilar because as you have noticed, their denominators are not the same. The first, the denominator of the first fraction is 6. The denominator of the second fraction is 4. So we cannot add them immediately, but rather we can create opportunities for them to become similar. The denominator that we are looking for, uh, we are going to use here, or we are going to take the concept of the LCD, or the least common denominator, or its complete name, which is actually least common multiple of the denominators. When you say multiple, it is actually, if we say 3, the multiples of 3 are when we add 3 to itself. You have 3 plus 3, 6 plus 3, 9. In this case, we're going to look for the LCD, or the least common multiple of the denominators. So 6, the next number for the multiple of 6 is 12. It is also possible for 4 because 4 can become 8 and can become 12. So the least common denominator is 12. In short, we can write these two fractions in terms of denominator 12. The purpose for this is for us to make it easy to add later on. So when making the denominator of the first fraction into 12, we simply multiply 2 to 6. Here, we're actually generating equivalent fractions as discussed in your module. We are trying to get the equivalent fraction. So when we try to change change 6 to 12, we multiply it by 2. We simply also multiply 2 to the numerator. So negative 1 times 2, you have negative 12. To check whether our equivalent fraction is actually the same as the original one, try to simplify. 2 and then 12. We know that 12 is 2 times 6, so we can cancel out 2. We still have 6 in the denominator, and we have 1 in the numerator, so it goes back the same. Okay. As for the second fraction, you have 12. From 4 to 12, we multiply it by 3. In generating equivalent fractions, multiplication is the process, not addition. It doesn't say from 4 to 12 we added 8, so we add 8 also in the numerator. It's not about adding, it's not about subtracting, it's multiplying. So from 4 to 12, we multiply by 3. We also multiply the numerator by 3, so we have negative 9. Now that we have the same denominator, we can just simply combine them and place one denominator and operate the numerators here. Operate. Okay, so you have here negative 2 plus negative 9. Again, when you look at the numerator, that is actually um, operations of integers. So you have to add negative 2 and negative 9, adding numbers with same sign. So 2 plus 9, 11, copy the same sign over 12. Again, you don't need to give us the decimal value of each fraction. Stay as fraction. If it's improper, stay improper, and always simplify if possible. Number 3, you have here 7 halves plus negative 2. Negative 2 here is actually a whole number. No, 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 sorry. Is an integer. To add a fraction and an integer, we need to change the integer into a fraction. We all know that integers can be represented by a fraction of denominator 1 because any number with denominator 1 is the number itself. Example, 1 million over 1, 1 million. Negative 500 over 1, negative 500. Let's say square root of 5 over 1. It's still square root of 5. So any integer, any expression can be written as a fraction of integer 1. The purpose for this is by determining the denominator 1, we see that the two fractions now are dissimilar. So we proceed again in finding LCD, which is actually just simply 2. So you have here 7, and you have here, because you multiply it by 2, you also do it for the numerator. So you have negative 4. And then we copy the denominator, and we operate the numerators. So you have here 7 plus negative 4. Operation of integers tells us that the answer is 3 halves. Again, this is already in a fraction form, specifically improper fraction form. Please do not transform it into a number with decimal notation, nor mixed fraction. We will need to stay as a proper fraction. As for the last item, you have here negative 3 plus 4 fifths. So again, negative 3 can be expressed as negative 3 over 1 plus 4 fifths. These similar fractions now, we need to take to make them similar with denominator 5. From 1 to 5 is multiplied by 5. We also multiply the numerator by 5. So you have negative 15 and then 4. And then we simply add them because they are now similar with denominator 5. Negative 15 plus 4. Okay, we are going to operate the numerator only. So you have negative 15 plus 4. We leave negative 1 over, I'm sorry, negative 11 over 5. So again, these are now all in fractions, but when you look at the numerators of your operations, you're going to go back to integers. So please review also integers. So the key here, the important concepts here is first, before we add, we look for similarity. If they are dissimilar, we use LCD, okay, or the LCM of the denominator, its complete name. And if we have integers, convert integers as fractions and probably use again LCD. So this is the content of the first video for lesson number 3 concerned on addition of fractions. Hopefully you've learned something and be excited for the next video. Goodbye.